Okay, I had to start over because the recorder stopped. So here we go. We were down to here where it says, are there outliers, excuse me, here in the test score example. But instead of the test score example, I'm going to go back up to the stem and leaf plot that we had and draw a box plot. So we're using this data here. I'm taking all of this information that we've already found and bringing it down here. Okay. So from that stem and leaf plot, the minimum was 12, the median was 76, Q1 65.5, Q3 88, and a max of 100. We can now look to see if there are outliers. So first off, we find the lower fence, which is Q1 minus 1.5 the IQR, so 65.5 minus 1.5 the IQR, and the IQR again is Q3 minus Q1, so 88 minus 65.5 would give you 22.5. And if you crunch those numbers, you should get a lower bound of 31.75. For the upper fence, or the upper bound, we're going to do the same thing, but this time we do Q3, so 88 plus 1.5 the IQR, which will give us an upper bound of 121.75. Well, our maximum value is 100, so we don't have any outliers here, but our minimum value is 12, which is definitely below 31. So we can go back up to our raw data. 12 is below it, but 37 is not. So 12 is our outlier. So for our box plot then, we're going to make an outlier at 12. It means our next min is at 37. Then we're going to go to Q1, which is at 65.5. Our median is at 76. All right, our Q3 is at 88. And our maximum number was 100. So then we just draw in our box. And it shows us how much everything is spread out, as well as that we have an outlier. Okay, I'm going to read the last part to you, and it says, box plots are nice because we can quickly identify the center and the spread. We can also identify symmetry or skewness, but not how many modes a distribution has. Box plots are especially useful for comparing distributions, but make sure they're on the same scale. And that's a back-to-back box plot, just like we have a back-to-back stem and leaf plot, and we'll talk about that in a little bit. All right, last page, cumulative relative frequency distribution. Instead of wanting to know what percent of the data falls into a particular class, we often want to know what percent of the data falls below a certain value. To make this possible, we will compute the cumulative relative frequency. For each class, which is the sum of the relative frequencies of that class and all the classes below it. So what I have here is the distribution of test scores. Okay, scores from 0 up to but not including 10, there were 2 of them. 10 up to but not including 20, there were 7 of them, etc., out of a total of 200 tests. The relative frequency, again, was found by doing the frequency divided by the total. So it's been filled in for you. And all the cumulative frequency does is adds them up. So we have the cumulative and the relative cumulative. So here's the cumulative. That would be 2, because there are only 2 up to here. And then the next one would be 2 plus 7, or 9. And then the next one would be 9 plus another 9. And we would have 18, 30, and so on. Okay? Then the cumulative relative frequency, okay, instead of just the cumulative frequency, we do the same thing but with the percents. So we have 1%, and then we have 1% plus 0.035, so 0.045, plus another 0.045, and we have 0.09, and that would go all the way up to total 100%, and this should add up to all 200. So I'm going to ask you guys to fill this in on your own. Okay. And then we could ask some questions, okay? What proportion scored less than 30? Well, I'll do one more and say at 30 we had 15. What proportion scored less than 30? Well, including 30 was 15%, so the proportion that scored less than 30 was 0.09, or 9%. Okay, see if you can answer the rest of these questions, and we will stop there, and I will check this next time.